I'd like to start the STEM and IT panel with the presentation of Dr. Marius Stan, former senior scientist and leader of intelligent materials design at Argonne National Laboratory. He's the senior fellow at the University of Chicago and Northwestern University. Dr. Stan is a research and author in Chicago, and you might recognize him from movies or pop culture. He obtained his bachelor's degree in physics from the University of Bucharest and his PhD in chemistry from the Institute of Physical Chemistry at the Romanian Academy. After moving to the US in 1997, Dr. Stan was a senior scientist at the Los Alamos National Laboratory and National Director of Modeling and Simulators at the US Department of Energy during the Obama administration. He later became the leader of the Intelligent Materials program at the Argonne National Laboratory and associate professor at the University of Chicago and the Northwestern University. Dr. Stan uses artificial intelligence and then high performance computer simulations to understand and predict the properties of complex systems with applications in energy, electronics, and national security. He has extensively published in scientific literature and holds several patents. Recently, he decided to devote himself to personal projects centered on the use of AI in science, technology, and arts. Dr. Stan gives a series of talks on the topic of international events and is currently writing a book on human and artificial intelligence, which might be of interest to Senator and Ambassador Jim Rosenbaum. Dr. Stan, the floor is yours.
Thank you for the introduction, and thank you for inviting me to give a talk on a rather technical topic, but I hope it's not going to be too boring. And I'll try to make a connection to the interconnections between the United States and Romania. So how about I'll share my screen. Do you see my screen?
Yes.
How about now? Is it a full screen?
Yes.
Okay. So briefly about the changing role of computing, of computation over the last decades. And I'm going to start with the 1950s, right after the Second World War. In Great Britain, at the National Physics Laboratory, Alan Turing assembled a team that created one of the first large-scale computational machines. But this machine was able to do only additions, subtractions, multiplication, and so on, way faster than any human being. So it was more about crunching numbers. These numbers, however, led to deciphering the communication code that the Germans were using during World War II. If you saw the movie, The Imitation Game, it tells the story of that. Now, two decades later, computers started to make a different impact on science, technology, and society. They were able to create documents and pictures and tables, and suddenly all the information that was stored in printed books and reports and was now available with ease and was searchable too. That represented a big change. I wrote my PhD thesis back in Bucharest using the software WordPerfect. And the thesis turned out to be perfect indeed. Now in the 90s, there was another transformation, high-performance computers that will operate at terascale, pentascale. Now we're heading towards exascales, millions and millions of operations per second, allowed scientists and engineers to simulate natural phenomena, such as transport of heat or diffusion of chemical species and so on. So it was a moment in time when computers will help us understand nature better. and predict the evolution of natural systems. I would say that as we were crossing from the last millennium to the new one, a new area of expansion for computing appeared, data management, collecting, retrieving, storing huge, tremendous amounts of data at a speed that was increasing every single month. This is a picture of Watson, a machine created by IBM, a machine that was deemed at some point to be the most knowledgeable entity on Earth. It would know everything about anybody, any topic. It wasn't, however, an intelligent machine. And I propose to you that we are living in a time, in a moment in time in history when computers are now playing a different role. They are advising people. They are members of research teams. They are members of governmental teams and caucuses in Congress advising not only scientists and engineers, but politicians, policymakers, lawyers, doctors, about how to make the best possible decisions. And even more frightening, some of these codes are making decisions by themselves in an autonomous way. But it's not that scary. The situation is not that scary. So let me go to a couple of examples, because it's pretty vague what AI is, what it does. Without being too technical, I hope, I'm going to give you two examples to reinforce the power of this technology. First of all, as I landed in Los Alamos in 1997 as a postdoc with an H-4 visa, talking about visa, I soon assembled a team of physicists and chemists and mathematicians and try to develop a code that will help us understand how atoms move in solids and liquids. And here's an example of gallium atoms. Gallium atoms are not pink, but we color them pink so we can follow their motion with more ease. I want to make the connection with Romania. One of the prominent members of our team was a Romanian postdoc from Bucharest, who spent 3 years with me at Los Alamos and then returned to University of Bucharest to Department of Physics at Magurele, and became a professor there, and at some point for a short time was the dean of the Faculty of Physics, as they call it over there. So Romanians are very good when engaging in science and technology. All Romanian immigrant students I had were exceptionally gifted. Now, in 2010, we decided that we want to see more people as a family. My wife is Liliana, is a scientist too. And we moved to Chicago. Now, imagine Los Alamos is 20,000 people, Chicago is 9 million, and has a community, a Romanian community of over 100,000 people. So in Chicago, at Argonne and University of Chicago and Northwestern, I had an opportunity to teach and interact with students. Somebody mentioned mentorship here. To me, this was perhaps the most rewarding part of being associated with these two prestigious universities, interacting with students during classes, but not only. This is a picture in the dorm. They invited me, and we had a discussion about the intersection of computing and art and physics and movies and stuff over a beer and so on. Young generation is the one that will advance and make dramatic changes in the way we use technology and science in society. Going back to the lab, I rarely go to the lab to do experimental work. They usually don't allow me. They feel that as soon as I step into the lab, something weird will happen with the equipment. But this is an example of a project that illustrates the power of artificial intelligence in practice, not in theory or in the newspaper articles. The experimentalist, the technologist here on the left, Joe Libera, is setting up an experiment that involves throwing a bunch of chemicals in a flame. And what can be more dangerous than that, right? The flame's pyrolysis produces powder, with particles of a certain size distribution. To the right, we have a couple of postdocs that were working with us. So humans usually monitor the behavior of the flame and in this highly dangerous, I would say, risky experiment. And we asked ourselves, is it possible with help of artificial intelligence to create a program, a software that will monitor this explosive, let's say, in quotation marks, experiment the same way a human does? Can we trust that software with doing that, even in the absence of the human? And here is, again, this is not going to be a talk about AI or machine learning or deep learning. If anybody is interested, we can talk about that. But to give you an idea, what happens is elements of artificial intelligence, in this case, image recognition, associated with a convolutional neural network algorithm, and machine learning, in this particular case, supervised machine learning, deep learning, are used to create a powerful and intelligent software that can monitor that flame. And it operates, in this particular case, pretty much like the humans do. We look at the flame, our brain processes the images. The tremendous difference between this type of algorithms and the classical one that we were using 20 years, 30 years ago is that there are no decision trees and there are no instructions, explicit instructions for the program about how to make decisions. There is nothing like, if temperature is higher than I don't know what, then turn off the oxygen. Or if concentration is smaller, then do this or that. Nothing like that. The algorithm is trained using experimental data from the human technologists, hundreds of video clips, thousands, tens of thousands of images, successful experiments as well as failed experiments. And somehow, through a magical way of processing this information that even we, those who write the code, don't understand fully, the software learns, gets an education, is being trained much like a human, like the postdocs I showed you, and is able to make decisions that can bring back to normal the state of the experiment. And here is an example. This is a video clip. This is not real time. We are not connected to Argonne National Laboratory, but it's a video clip that shows how that works. On the lower left corner, you will see the flame, the actual flame flickering from the experiment. In the upper right one, you will see the size distribution of the powder. The intelligent software, in the absence of the humans, detects the fact that this flame is unstable and the powder doesn't have the right distribution and takes the corrective actions by itself. So the flame on the lower left, I hope you can see it. On the upper right, you will see how the size distribution is being changed to bring it to normal. This is a good thing. You may wonder, of course, the technologist was at first scared. I'm going to lose my job because of this software. He didn't. He learned how to operate, how to use this software to his advantage, how to even contribute to making the software even better. The code is nothing. AI is nothing without the humans who train the algorithms, who use the software, who are capable to control, to put some limits to what artificial intelligence can do. I was lucky to have this wonderful team with mathematicians and physicists and chemists. And we were also lucky to get students, young people. Here is Jessica Pan from Princeton. She spent 3 months with us, only 3 months, but she was so creative. She was so good at everything she did that although in undergrad, she was a junior in undergrad, we decided not only to add her as a co-author of the paper, but to make her the first author of the paper. How often do you see that in an undergrad? We even contemplated adding the software, Python code, as a co-author of the paper. That was an interesting debate we had. We decided against it at the end because we thought that the contribution of the software was not creative enough. It did a lot of work, tremendous amounts of work, processing data, but didn't come up with any good idea, in contrast to the student who was absolutely instrumental in the progress of the project. So, let me see. Yeah, okay. I claim, and I said this in several presentations in the United States, in Europe, in Canada, and here, by 2035, we will have a software, an artificial intelligence-based software, co-authoring a scientific journal. And by that, I mean that the article will pass peer review and is going to be a decent, prestigious, perhaps, journal. So this is not a joke. I think this software is changing the way science and engineering are evolving. But let's go back to connection to Romania. I want to mention here that after leaving Argonne, retiring from Argonne 2 years ago, I decided to dedicate my time and energy to using artificial intelligence in a broader context, maybe having an impact not only on science, but on art and on society at large, complex system. And part of that was spending 3 months every spring, usually April, May, and June, in Romania, and giving, I guess there are more than 30 talks about topics such as artificial intelligence in science at the Romanian Academy or University of Bucharest or Iași, or artificial intelligence in art at the Brukenthal Museum in Sibiu. And talking with the government, usually the research part of the government, Mr. Burduja in the past, Mr. Ivan, I think he's now, and talking about how one can use artificial intelligence to impact in a positive way various parts of our society. These talks, which are free of charge, and by the way, are in Romanian. I chose this picture because the background shows that they are indeed in Romanian, and I don't get paid for doing this. It's just a way of giving back to the country that educated me and gave me the basis and the strength and the energy to pursue science and engineering. So I love doing that. I'll go back next spring, no doubt about it. In Chicago too, I live in Chicago and we have a vibrant Romanian community, as illustrated by the Romanian United Fund and Rocco. I'm sure Mihaela Hene will say more about that. The fact that we have a Romanian film festival is really exciting for me. I really like movies. And maybe Mihaela Campion will say something about Archer and that organization. They are heavily involved in organizing these festivals. So there is an environment that makes me hopeful and excited about the use of this technology and about the fact that we should embrace it and control it rather than fear it and reject it. Now, I like to write literature. Mr. Theodor Stan said I should say a few things about me because you may not know me at all. I haven't been part of these kind of discussions in the past. I published in Romanian short stories and poetry. And of course, I should mention here that there is a danger that parts of artificial intelligence can negatively impact literature. We are living in times where students use ChatGPT to do their homework, to write reports, to even there are attempts to create literature, even visual arts, paintings, drawings, graphics, using computers. And there is no time for such a discussion, but I'll be happy to talk with anybody who is interested about the limitations, the power and the limitations of this technology. Because ChatGPT can go really wrong, can even hallucinate at some points. But I'm going to end with a more optimistic view, if it can be more optimistic than it already is for me, by contrasting the capabilities and the power and the subtle complexity of the human brain, of the human intelligence that has intuition, can display critical thinking and common sense, and above all, is creative. Moreover, humans have self-awareness, which is something that artificial intelligence does not have here. They know they are humans, and humans have a system, an axiology, a system of values, a set of moral values, which AI does not have yet. So this contrast and the way human and artificial intelligence can complement each other is something I discuss in the book titled Human and Artificial Intelligence. As you can imagine, it's gonna appear next year. I'll be glad to discuss more about it, or if you shoot me an email, I can put you on the distribution list and will notify you when the book comes out. So I'm gonna stop here. I don't know if we have time for any questions, but I'll put some information in the chat and we'll welcome your comments and especially criticism, especially comments that can incite vigorous debate. And let me just end with the hope that the Romanian and American professionals will find new ways of working together, either remotely or by visiting each other, I've heard a lot about Romanians coming to the United States with all kinds of visas and how can we remove the visa. How about American scientists going to Romania and giving talks and interacting with people there and creating these bridges that may last for generations? So I'll stop right here. Thank you.
Most definitely, that will be helpful. And if I may mention, this spring, since last year, we announced the Smart Diaspora 2023 conference in Timișoara. We caught up in Timișoara as you were presenting. You were part of the brain map that the Romanian government has developed and welcomed to bring the expertise to the country. And you're doing such a terrific service to the country and to the upcoming generation of researchers there. And we can only hope that we can do the reverse of bringing Romanian researchers here in the United States and having them visit the labs that you've worked with and that you are a member of. I think that would be a great resource, and have Romanian and American labs work together in co-authoring papers. Again, of course, you mentioned the local community partners there that assist in you being connected with the country of origin, RUF and ROCO, and all the organizations. I'm happy you mentioned them. I think Mihail Hene was here, but I'm not sure if he's still on. We will have them tomorrow. We will also have Archer tomorrow in our panel sessions. Thank you again for comforting us that AI is a tool. It's a tool of our creation, and we shape it with our ethics and possibly with our flaws. But let's hope that's not the case. We used as humans, we feared electricity, we feared radio, we feared the television for good and bad reasons. But
let me just say that a century ago, I found a journal article that showed the fear of automobiles, and it was something like that. These machines are going to kill grandparents and children and chickens and dogs because they are running with the amazing speed of 5 miles per hour. So that was the fear of the time. I would say that we will learn, as we did in the past. So, human society is robust.
Tools come with challenges and also force us to adapt and evolve our ethics. And you've done such a terrific job in portraying that. Thank you so much. We're running again way behind the schedule.